This is the run speed gene. We are using mice and the ability of the mice to run away from predators as the trait that they are being selected for or against for natural selection. So you're going to get with a partner and you're going to have a cup for each person. You'll have 25 red beads, which will be the faster gene, and 25 white beads, which will be the slow gene. So red will be big R and white will be little r. You're going to each draw a bead out of your cup and record your genotype. So you can see on offspring number 1, one of us drew a red bead and the other partner drew a white bead. So we have recorded big R, little r for our genotype. Then you roll the dice and you record the roll. On the front of the lab, it will tell you if that mouse was fast enough to escape or if it died. Once you complete all 20, you will put the beads back as you go. So every time you draw out, there will be 50 beads in your cup and 50 beads in your partner's cup. And you will do this all 20 mice. Then, when you're done with that, and you figure out if those mice live or die, you're going to come down to the bottom and do some calculations to see the gene frequency of the big R and little r allele. So you can either follow the guidelines they have set for you right here. They give you a formula. I just simply go through and count them. Everywhere there's the word escape written, I count all the big R's first. For example, on offspring 5, that gives me 2 big R's. That's just one individual, but those are 2 big R genes. So you have to count that twice. And that's what it means down here about number of big R genes. And it says number of RR survivors times 2. So I just go through and all the ones that say escape, I count up how many times I see a big R. So you can see on line 5 there were 2. On line 11 there were 2. On line 13 there were 2. On line 16 there was 1. And on line 17 there were 2. That gave me a total of 9. Then the next thing you want to do is the same thing for the little r gene. Again, you can follow their formula that they give you. I think personally it's just easier to just count them. So I see that the only one, line 16, that escaped had 1 little r. Every other mouse that had little r was, I guess, too slow, and so they died. So to calculate the gene frequencies, I had 9 total big R survive and 1 total little r survive. That's a total of 10 genes in all. So to calculate the ratio for the big R, I had 9 out of 10 times 100 gives me 90%. And for the little r, had 1 out of 10 times 100 gives me 10%. So already, which probably won't work out for you this way. Oops, hello, light went out. You'll probably start off with bigger frequencies and then work down to this as you get to like the third round. But that just means that I'm only going to put 9 red beads and 1 white bead back into the cup for myself, and then my partner will do the same thing, and then we will begin round 2. You do not put the genes of the dead mice back into the cup for the next round. I've set out a clear petri dish for the morgue, and they can stay there until you may need them again. If you have any questions, ask one of my TAs or ask Coach Walling. Thanks.